A few people have contacted me because they don't understand how to do bandwidth. Now, most of you seem to understand this kind of thing where you're given a graph and you have to work the bandwidth out. It seems to be the other way around where you have to draw the graph. But I'm going to go through this first just to make sure that you understand it. So this is a graph for a single amplifier. So it's a specific amplifier and it's showing you what its voltage gain is up here and then the frequencies that it works at down here, because different amplifiers work for different frequencies. And as you can see, they work really well for a voltage gain here up to about 3000 Hertz. So this amplifier works perfectly up to this point here. And then anything, any signal that's higher than that, so a really high-pitched signal, it starts to work less and less well for. So we need to work out the bandwidth. So the bandwidth is an indication for somebody who's buying the amplifier or making the amplifier as to what range of frequencies it works at really well. We determine that an amplifier works really well at 70% of its maximum gain. So this is where 70% is. So providing that it's doing everything well at 70% of its gain, we think that it's an amplifier that is suited to the job in hand. So to work out a value for bandwidth, what we do is we look at the gain. Now I'm looking on this one, it's 100, so it's easy to work out, but I need to work out 70% of it. So I need to work out 70% of whatever this gain is. So it could be 20, 30, 40, it doesn't matter. And an easy way to do that is to times by 70 and divide by 100. Or that is equivalent to times in by 0.7. So if I got my maximum gain here is 100 and I times it by 0.7, that will equal 70. So obviously, like I'm saying, that's an easy one to do because this is 100, but you can apply this same formula to any value for the maximum gain. So I now know that at 70% of the maximum gain, it's here at a value of 70 there, and I can then put a dotted line, or I can just put a straight line across here, and I can draw it up to where it hits the curve. So this is the curve for a specific amplifier. Now I can see it hits the curve there. So if I draw downward from here, I can see that this amplifier works really well, or it works up to 70% of its efficiency from 0 down here all the way across to 5000 Hertz. So that means that the bandwidth, what we call the bandwidth of this amplifier, is 5000 Hertz. It goes from 0 to 5000. It's a 5000 Hertz bandwidth amplifier. Now that would help me if I'm choosing to buy an amplifier. I could look at the bandwidth it's going to work with. If I thought it needed to be suitable for a vocal range or for a bass guitar or for some high-pitched whistling or something, I could choose an amplifier that suited the range of values that I need it to work with. Okay, so the thing that lots of people are struggling with is this kind of question here, and this is asking you the same question but in reverse. You are trying to work out what the curve on here will look like, where it will go from some information that's been given. So the first thing I'm going to do is I'm going to find out the relevant information. So I know that this preamplifier has got a voltage gain of 100. That means its maximum gain it can do is 100 times the input. And it has a bandwidth of 2000 Hertz. So if you remember from the last thing, that means that the bandwidth, the place that it works the best is from 0 down here up to 2000 Hertz. So I know that in this range the amplifier is going to work to 70% of its capacity. To draw the graph then, there's a few things that I need to know. The first thing is, like I said, I know that the maximum voltage gain is 100. So I'm going to draw, without even working anything out, I know that this is where the maximum voltage range is. The maximum gain is. So it's a bit hard to see there, I haven't drawn it well enough. So I'll just darken it up. So I know that there, I've done it as a dotted line at the moment, that is the maximum voltage gain that this amplifier will give me. So if we look back at our old graph, I've now worked out this line here. So this bit here, that bit there, is the maximum line, the maximum voltage gain that I'm going to get out of that amplifier. But I need to work out where this diagonal line goes, and the only way I can work that out is by working out this point here. And I know that this point here is at 70% of the voltage gain, and it's at the maximum bandwidth. So I know that the maximum bandwidth and the voltage gain here will give me a point here that this curve must go through. So to work it out properly, I'm going to need to work out what 70% of the voltage gain on this amplifier is. So I'm quite lucky again, this is 100, so working out 70% is 100 times 0.7, but this could be anything, this could be 50, 20, it doesn't matter. Times it by 0.7 and you'll get the value here of 70% of its maximum gain. Now it just so happens that because I'm working with 100, 70% of the maximum gain is 70. So now that I know where my 70% mark is, I need to use this information here for the bandwidth, 2000 Hertz. And I know that a bandwidth of 2000 Hertz means that it works well at 2000 Hertz for 70% of the gain. So I'm going to draw a line up here. Again, I'm going to draw a dotted line. But I can see it crosses there. I know that it crosses here. So that means, looking back at my old graph from the previous question, I know that it's got to go, the line's got to go through that point there. So I know it must come along this line here because that's 100%. I know it's got to go through there, but I don't really know anything else. Now, in an exam situation, all you are expected to know, or all you're expected to do, is draw the graph roughly as it would be. And roughly, it would be a solid line here, and I know it would be a solid line through here. Okay, don't worry about the angle. You won't get marked down from that. You can't work out this exact angle properly without doing lots of tests on the amplifier. But what an examiner wants to see is that they want to see that you know that this amplifier will have a straight line here and it will have a diagonal line going through this point here. Now then you should have a smooth curve between them. Okay, so it should be a smooth curve between them. Now this angle could be in a few different ways, but for an exam question, and to be honest, for practical purposes, all you need to know is you need to get this line correct. So that has got to be right. You've got to have it going through this point here, and you've got to have a curve here between the two lines. That will get you the full marks in an exam, and a graph like this will help you loads with your practical work. So I'm hoping that that helps. Please contact me and let me know if you don't understand it, or if you need more clarity on any part of this information that I'm giving you.